Hello students, now we will discuss more problems related to Maxwell's loop analysis. In previous class already I told you the theory of Maxwell's loop analysis, how to find out the loop current I1, I2, I3. Now we will do more number of problems so that your fundamental will be clear, and this type of examination this type of question will ask in your GATE examination and IAS examination. So now today I will discuss some more critical problems. How will you approach the problems so that your fundamental will be more and more clear. This is one of the problems related to Maxwell's loop analysis. In Maxwell's loop analysis, already I told you, if there is a current source, then we must be converted into voltage source. So here this is one loop, another loop, and this is also loop. In this problem you will find there is a current source here. So in this current source, if there is a current source, you must be converted into a voltage source. This is a current source. If there is a current source, then you have to convert it into voltage source. Already I told you how to convert a current source to the voltage source. If there is a current source, there is a resistance parallel to this current source, 2 ohm, and is 2 ampere. You will convert it, that is your what? 2 into 2, that is your 4 volt, and the resistance will be 2 ohm. After another figure, you have to rerun the another circuit, and this part, a current source can be converted into the voltage source. So that will be if you will rerun the circuit, in place of this you will put, there is your what, in place of this current source there is a voltage source minus and plus, and the resistance is like this 2, there is your 4 volt, and this is your 2 ohm. Okay, this current source can be converted into the voltage source. Already I told you, if there is a voltage source, put the direction of voltage source is your minus to plus is plus, here minus terminal and this is your plus terminal. The direction is like this, here minus to plus, the direction will be like this, here minus to plus plus, the direction of voltage source like this. So again the loop current here, this is your third loop, I3, this is your 3 loop, loop 1, loop 2, and loop 3. If there is a 3 loop, there is your 3 into 3 matrix, resistance matrix. So the resistance matrix into current matrix, and then is your voltage matrix. So R, if there is a 3 loop, there is a 3 into 3 resistance matrix. So R will be how much? R11, R12, R13, R21, R22, R23, R31, R32, and R33 is your 3 into 3 resistance matrix, and 3 unknown quantity here, currents I1, I2, I3. We are going to calculate I1, I2, I3. The 3 unknown values are I1, I2, I3. This is your I1, this is your I2, and this is your I3. Then voltage matrix, that is your V1 net voltage in the loop 1, V2 net voltage in the loop 2, and V3 net voltage in your loop 3. V1 is the net voltage in the loop 1, V2 net voltage in the loop 2, and V3 the net voltage in the loop 3. Then what you will do? So this is nothing but R11, already I told you. If R11, the sum of the resistance formed by the loop 1. The sum of the resistance formed by the loop 1. How many number of resistance in the loop 1? This is your 2, this is your 1, and this is your 3. The total resistance is your 2 plus 1, 3 plus 3, 6. Here R11 is your 6. Then R12 is your the resistance 2. Here loop 1 and here loop 2. The common resistance is your 1, and put the minus sign. R12 is your 1 and put the minus sign. Then R13, this is your loop 3 and this is your loop 1. Is there any resistance common between 1 and 3? Yes, common. There is 3 of resistance is common between the loop 1 and loop 3. So that is your 3. In place of R13, you will put 3 and put the minus sign. This is your R13. Then come to 2 1. 1 to 2 1 is same. 2 1. The common between 1 and 2 is 1. Put the minus sign. R21, that is your minus 1. Then R22. Self loop 2. In loop 2, how many number of resistance? 1, 2, 3, 4. 4 resistance. And sum of the resistance is 1 ohm plus 1 ohm 2 ohm plus 3 ohm 5 ohm plus 1 6 ohm. So total resistance formed by the loop 2 is your R22. So 1, 2, 5 plus 1 6. The total resistance in the loop 2 is your 6 ohm. So R22 is your 6. Then come to R23. 23 is your the resistance common between the loop 2 and loop 3. And 2 3, is there any resistance common? Yes, the 1 ohm resistance is common. So here 2 3 1, and since it is a common resistance, put the minus sign. Are you clear or not? Then R31. 31 is same as 1 3. This is your loop 3 and this is your loop 1, and the common resistance is 3 ohm, and put the minus sign. And 3, that is your minus sign. Then 3 2. 3 2 is your loop 2 and loop 3. Loop 2 and loop 3, the common resistance is 1, and put the minus sign. This is your 3 2. Then 3 3. 3 3 is your self loop 3. This is your completely loop 3, and the total resistance formed by the loop 3. 3 ohm plus 1 ohm 4 ohm plus 2 6 ohm, and this is your 6. This is your R33. So R33 is the sum of the resistance formed by the loop 3. Here the diagonal is nothing but your self loop R11, R22 and R33. This R11 is your sum of the resistance formed by the loop 1, 1, 2, 3. If you add all these 3 resistance, you will get this. R22, sum of the resistance formed by the loop 2, 1 plus 1 plus 3 plus 1, this one. And R33, sum of the resistance formed by the loop 3, the diagonal. Except the diagonal, all are common between 1 2, 2 1, 2 3, 3 2, like this, and put the minus sign. And this is the resistance matrix, has already been formed. This is your resistance matrix. And then current matrix, that is your I1, I2 and I3. Then this is your unknown values where we are going to calculate. Then net voltage V1. So already I told you, this your V1 is the net loop voltage. If V1 refers to the loop 1, the net voltage of the loop 1, already I told you the direction of the voltage source, if the same as the current source, take as positive, only one voltage source. The current direction, this I1, the same as the voltage direction, that is your plus. So in place of V1, you will put 2. Then come to V2, loop 2. In loop 2, if you found only there is a one voltage source here, and the direction is like this, and here the current direction is opposite to the voltage direction. This loop current direction is opposite to the direction of the voltage source, and put the minus sign. In place of V2, you will write 3 and put the minus sign. If the direction of the current source is opposite to the direction of the voltage source, put the minus sign. Then come to V3, and here this is a loop 3, and the direction of voltage source is like this, and here the current direction is clockwise, is opposite to the direction of the voltage source. Then put the minus sign. And 4, this is your 4 volt, net voltage is your 4, and put the minus sign. This is your required voltage matrix. So in this, resistance matrix and current matrix equal to your voltage matrix. From this, we will calculate I1, I2, I3, 3 unknown values I1, I2, I3 using Cramer's rule. Using Cramer's rule, we will find I1, I2 and I3. Now, first of all, we will calculate the resistance matrix value of R. This is R. How to calculate R? So you will find out the value of this matrix, and the R value, how to calculate R? 6 into this and this into this. Okay, 6 into 6 into 6, 36. That is your 36 minus plus minus minus. That will be 1 into 1 1. Then middle term, that will be plus minus minus plus 1 whole into, if we will consider this one, that means this into this minus this into this, minus 1 into 6 minus 6, that is your minus 6 minus here minus minus plus minus minus 3 into 1 3, that is your minus 3 again that is your minus 3, minus 3. So minus 3 whole into, if you consider this one, if you close this and this, you will get this value. So minus 1 into minus 1 plus 1, minus minus plus 1 plus 9, 1 plus 18, 1 plus 18. If we simplify this, the value will be how much? 6 whole into 36 minus 1, 6 into 35. Here minus 6 minus 3 minus 9, minus 9 to 1, that is your minus 9, minus 9. Here 18 plus 1 19, 19 minus 3 into 19, minus 3 into 19, minus 3 into 19. The value is how much? This is your 210 and this is your minus 9, this is your minus 57 and the value will be, that is your 210 minus 9, 201, 201 minus 57. The value will be your 4, 4 and here 1, 144. The value of resistance matrix, the value of this is your 144. Then the value of R here, that will be your 144. Then how to calculate I1? The I1 is nothing but, that is your R I1 divided by mod R. So R I1, the I1 value is your how much? When we are going to calculate I1 using Cramer's rule, simply you close the first column, you will get this column 2, minus 3, 4, minus 4 here. Then except I1, first you will take this one, then minus 1, 6, minus 1, then minus 3, minus 1 and 6. This divided by R is your 144. The value is how much? Here same thing, 2 whole into 6 into 6 36, minus minus plus minus minus 1, then minus minus plus, this 6 into minus 3 minus 18, minus minus plus minus 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 4, then minus 3 whole into minus 3 into minus 1 plus 3 minus minus plus 24. This divided by what? That is your 144 and the value of I1 equal to, if you will solve the numerator, 36 minus 1, that is your 35, 2 into 35, 2 into 35, that is your 70, that is your 70, then minus 18 minus 4, minus 22, minus 22 into 1, minus 22, minus 22, here 24 plus 3, 27, 27 into 3, so 27 into 3 minus 27 into 3 divided by 144, which equal to 70 minus 22, 70 minus 22 minus 81 divided by 144, which equal to, this is your 81 22 103. So 70 minus 103 divided by 144. The value will be how much? 70 minus 103 divided by 144. So using calculator, first of all 70 minus 103, 70 minus 103, the value is your minus 33 divided by 144. The value is your minus 0.22. Here minus 0.229 ampere. Here the value of I1. The value of I1 the value of I1, we got the value of I1 equal to minus 0.229 ampere, the value of I1. Then come to how we will calculate the value of I2. How to calculate I2? How to calculate I2? Same procedure. The value of I2. Value of I2. I2 is how much? I2 equal to, when we are going to calculate I2 using Cramer's rule, simply close the second column. In left side you will find this column. First column you will take 6 minus 1, then minus 3. Then come to this one, 2 minus 3 minus 4. Then minus 3 minus 1, then 6 divided by this value, the resistance matrix, that is your the value of R already calculated, that is your R value, the value of R. So the value of this equal to how much? 6 into minus 18 minus minus plus minus minus, that is your 4. Then minus 2 into this into this, that is your 6 into minus 1 minus 6 minus minus plus minus minus, that is your 3. Then minus 3 whole into minus 3 whole into this into this minus this into this, minus 4 into minus 1 plus 4 minus 9 divided by R, which equal to 6 whole into 22 minus 22 minus 2 whole into minus 9 minus 3 into minus 5 divided by mod R. The value will be your 132 minus 132 minus 9 into 2 minus 2 18 minus minus plus 15 divided by R, which equal to minus 132 plus 33 divided by R equal to minus 99 divided by mod R. Already we calculated the mod R, value of R. The value of R equal to 6 whole into 36 minus 1 minus 1 into minus 6 minus 1 into minus 6 minus plus minus minus 3 minus 3 into plus 1 minus minus plus 18, that is your 6 into 36 minus 1 that is your 35. This is your minus 6 minus 3 minus 9 minus minus plus, this is your plus 9 here, then minus 19 into 3, that is your 210 plus 9 minus 57, that is your 219 minus 57, the value is your 219 minus 57, that value is your 2 6 1 6 into 36 minus 1 minus 1 into minus minus plus 1, here minus minus plus 1 whole into, that is your minus 6 plus 1 whole into minus 6 minus 3, then minus 3 into, that is your 6 minus plus minus 3 into, that is your 1 plus 18, that is your minus 9 here, okay. This is your 210 minus 9 minus, this is your 210, this is your 201 minus 57, and the value will be your 144. Okay, this is your resistance value, and the value will be how much here? There is minus 19 divided by minus 144. Value will be, using calculator, 99 divided by 144, 0.6875, that is your minus 0.6875 ampere. Okay, the value of I2 equal to your